All right, I think this is going to be a quick video. It's 4-5, the Rational Root Theorem, and I actually only use this to check my work in my head, so I expect you to know it because, again, you're going to be using your calculator, but you need to make sure your calculator is giving you reasonable answers. So you better check out page 191, write down the Rational Root Theorem. I know it's not the best looking thing in the world, and it is super tedious, but I'll show you how I use it, and then later on when we do a huge problem, you'll see how I use it to actually just check my work. All right. As your example, I'm actually going to just skip to page 193, number 6. I'm not following the directions. I'm just using this formula, this equation, to show you what the rational root theorem is. So for the rational root theorem, you make sure that your function's in descending order, and then you go ahead and you circle the last number, the constant, and circle the leading coefficient, all right? These are our most important numbers. Now, we're going to create a fraction with all the factors of 12 over all the factors of 3. So all the factors of the constant over all the factors of the leading coefficient. That's what the rational root theorem breaks down to. All right, so to do that, I stay very organized, and I want you to stay organized as well. So I'm going to create a chart. What are my factors of 12? They are 1, 2, 3, 4, 6, and 12. Let me actually, these little whiteboards sometimes don't give me enough space. 1, 2, 3, 4, 6, and then 12. All right, here's my factors of 12, right? And they need to go over all my factors of 3. Well, what are my factors of 3? 1 and 3. So that's not too hard. So I'm going to put over 1. That's my first factor of 3. But I have another factor of 3, right? I have over 3. So I'm going to rewrite my factors of 12 again. And instead of putting them over 1, I'm going to put it over my other factor of 3. So did I just create fractions where in the numerator I have all my factors of 12, and in the denominator I have all my factors of 3? Yes. The last thing I need to do is put a plus or minus before everything. And we have some redundancies here. So for my answers, I have a 1. I have a 2, but you know what? That's the same as 2. I don't need that. I have a 3. Oh, not there yet. I have a 4, and that's the same as 4, so I don't need that. I have a 6. I have a 12. And then I have 1/3, 2/3. Oh wait, 3 over 3, I totally forgot. That's the same as 1, and 4/3. Don't forget your pluses and minuses. Now, these are all the possible being the key word here. These are all the possible roots of the equation from number 6. 3x to the 4th minus 2x cubed, yada, yada, yada. These are all the possible answers. Now, I don't always do this ahead of time. I am going to have you do it just for practice a couple times. But what I do is I keep these numbers in my head, not all in my head, but when I get an answer from my calculator to see if it could be the right answer, I think about whether or not it is a factor of 12 divided by a factor of 3. Okay, so that's the rational root theorem. It is all of your factors of 12 over all of your factors of 3. We'll do some more in class. It's a really weird looking thing, and again, it's the best used when you're checking your work to see if your calculator is giving you a reasonable answer. Okay?